Welcome to solverfy.
So for this question, we're trying to maximize the velocity v of the wind coming out of our windpipe, given the radius r, and the radius r must be between 1/2 RO and RO being the normal radius of our windpipe. So in order to do so, what we need to do is take the derivative of v. So we're gonna have v prime of r. That's going to be equal to, so we need to chain rule to this. So we're going to have, if we derive the r minus r, we're going to get negative k r squared, because the r minus r is just going to drive to -1, right? And then we're going to have plus a 2k r ro minus r. That's going to be equal to 0. And then next, I'm going to just move the kr squared to the other side. So I'm going to have 2kr. It's going to be equal to, 2kr ro minus r is going to be equal to kr squared. One of the r's will cancel out and the k will cancel out. So we'll get 2ro minus 2r is going to be equal to r. 2ro is going to be equal to 3r, or r is going to be equal to 2/3 ro. So this checks out with the experimental value given to us earlier in the question. Okay, so for part B, we're trying to find the absolute maximum value of V. So all we need to do is plug in this 2/3 RO into our V equation. So we're going to have V of 2/3 RO is going to be equal to K RO minus 2/3 RO, and then 2/3 RO squared. That's going to be equal to K times RO minus 2/3 RO is going to be 1/3 RO times 4/9 RO squared. Okay, multiplying this out, we're going to get that V of 2/3 RO is going to be equal to 4K RO to the third over 27. All right, and yeah, that should be our answer for that velocity v. Now for part C, we want to sketch a graph of v on an interval of 0 to RO. So we're going to start here at 0, and then RO, we're going to have 2/3 RO somewhere in between, right? And we know we're going to have a maximum there for V, given that 2/3 RO. And let's check out what V looks like when R is equal to 0 and when R is equal to RO. So when R is equal to 0, we're going to get that K RO minus 0, and then 0 squared, so that's just going to be 0. And then V of RO, that's going to be K RO minus RO. That's going to just be 0. So for both these points, mathematically speaking, we'd get 0. And the graph would look something like this, with a maximum value at 2/3 RO.